All right. Hello, everybody. So we are not meeting in class today, and instead I'm putting together this video with stuff on it, with the stuff we're covering. So you should all see a web browser window right now. And so this is going to cover what we wanted to go over for the most part today. And let's use Zulip for any conversation and support. And I'm going to, of course, post this to you with Zulip with an assignment for next week. Our next class being next Thursday, because Monday being the holiday. For those of you who were not able to make it today before they canceled everything, thank you for letting me know. Double props for the people who sent it via Zulip as opposed to email. But definitely, I appreciate you letting me know one way or another. I got the Hunter before I found out about it, so I had to set everything up to work on making these videos, and then I'll head out. All right, so this is that work repo that you all should have cloned the other day, or you should all have accepted the assignment the other day. And I'm just going to go through the setup for this again. And so we went to Repl.it, R-E-P-L-it, Repl.it.com. I guess it's also Repl.it as a website. And I'm going to log in. And the important thing here is when you log in using GitHub, all right, because we're going to ultimately link to GitHub. And then you're going to want to create a new repo. And then we're going to want to import from GitHub. And so that's going to be, I'm going to use this one, fall 2027, 127 work Zemansky. Of course, you'll use yours. I'll paste that there. Click it, import it from GitHub. Now, when you do this, it might give you an error, like it says you need to add the ID or something. If that happens, don't worry about it. I will get an alert, and then within a relatively short period of time, I'll be able to give you the permissions. You also might get a question up here somewhere that says, like, choose your language. Don't worry about that. If it says just add Python and click on done, and if it doesn't go away, just reload the page. But you'll notice that this, I'll make the font bigger, this maps out to pretty much the same thing that we have on GitHub. So we have a turtles directory, which has intro in it. And we have a turtles directory here that has intro in it. And so it's all linked. So if we want to work here now, and again, we can click here to make a new file, and we can click here to add a new folder. So, and to test things or to run things, let's go and click on IntroPy, and we'll see what that does. So I can click on the shell, not console, but shell. I can see I am in the main directory, so I want to cd into turtles, and then I can do Python intro.py, and it will run. And so we're going to do that. So I'm going to look at Zulip for a second, and this should not come up on your screen, I don't believe. But I'm just trying to see. Yes, I asked you to do a couple of things with turtles. And I didn't ask you to put this anywhere, but I'll put it somewhere anyway. So, like, let's say I wanted you to put this into a new folder called, I'm going to call this shapes. So I'm going to create that folder, and actually I didn't want to do that. Somehow this got moved, so I'm just going to drag that up to turtles. And I'm going to delete shapes because I made a mistake there. So notice this is just like using a regular thing. So I'm going to click out of that. I'm just going to reload the page. So just to show you that, like if it's a little clunky, you can always fix things. It's not a big deal. So what I'm going to do here, close that up. I wonder what this is. Is this the same intro? So let's move this into turtles. There we go. Now that is in turtles. Okay, so that's back where it was. Let's now add a new folder. I didn't want to add it there. Why is it? Let me click on this. Yeah, so now I'm not in a folder, so this might be better. So I'll click here on README. Now I'll add a folder. So yeah, so now it's just adding a folder. So just make sure on a file. We'll call this shapes. And now we're going to go into shapes, and we're going to add a file, and we're going to call this simple.py. And so we'll start our program. We'll import turtle. We're going to make a new screen. We are going to then, at the end of this, we know we're going to do a wn.exit on click, and we're going to do a wn main loop. And this is where we're going to do stuff in between. So we'll say crush equals turtle.turtle. And we know that we can, and I forget exactly the distances I said, but we know that we can say crush forward 50, and that's going to draw our first line. And so I'm going to come here and click back on my shell, do an ls. I have shapes, and I can do Python simple.py. For t.screen, I have to fix that for full. wn equals. So again, it's got to be very specific. So these are the types of errors that you may also do these as well. And this way, like I make them too. We all make them. So fixing all my turtles. Woohoo! And we know we can turn this by going crush right 90 degrees, exit that, and run it again. So that, or we can go left, I guess. But if we want to make a square, we do it 4 times. Ooh, we have a square. So we know the other thing that I asked you to do was to draw a triangle. And so for a triangle, we might say, well, we got to do this 3 times. So let's cut that, and let's paste that. 1, 2, 3. And we know this isn't going to work because this is going to, well, but let's just go to crush.goto 1010. Click that to close it. Ooh, that's like a 3D effect. That's kind of cool, but not what I intended. So let's actually go to, maybe we can go to -50, -70, -70. So that's looking better, but notice that it's doing this extra line, and that's because we have to do crush dot and up before we do our go to, and then a crush dot pin down afterwards, because that way it won't trace the movement. So these are other commands. And to make it a little differently, why don't we also say crush dot color. And from this, we're also learning that 0, 0 looks to be here in the origin, and these are the negative points. Now we know that's not a triangle, so we know clearly we're not turning in the right way. And I'm just going to put a little bit more here to say square, triangle. So you're going to try various angles, and most people first try as an angle 60. Oh, well, that's because I changed the forward, not the. Let's change this back to 50 and change the 90s to 60. And yes, we don't strictly need to turn at the end because once we finish drawing, but this will make it easier later on. But that isn't any good. But notice that shape is interesting for later on. It turns out that we are walking, if you think about this, if you're a turtle and you're walking around with this pen, if you walk around a triangle, you're kind of walking around the outside and you have to complete 360 degrees to get all the way around. So that would lead us to 120 as our angle. So like here for the square, it's turn 90, 90, 90, 90. So it's 90 plus 90 is 180, plus 90 is 270, plus 90 is 360. So we're walking around the outside of a circle in drawing it. And so by the same token, to do a triangle, we have to walk around 120, 120, 120, get us up to 60. Now, if we wanted to, we could keep going with this. We could say, let's say, hexagon. See if you can do a hexagon. That'll be a little bit of a challenge. So why don't we start it off with crush color green, and then crush dot pen up, and then crush dot go to, and why don't we go to negative 50, 50, and then we'll do a crush dot pen down. Okay, and that's going to move us there. Let's move us to 80. Let's move us a little bit higher. Okay, so stop the video here and spend a few minutes to see if you can write the code necessary in order to do a hexagon. All right, so 6 sides. So, or if you want, you can try an octagon or a pentagon, but we're just going to go over hexagon. All right, so stop this video and then resume it when you're done, once you've got something. All right, so if you've resumed the video, now we're ready to put in our hexagon. And so we know it's going to be moved forward by a certain amount. And I'm just going to move forward 10 to make it a little bit smaller. And then we have to turn right or left by a certain amount. And it turns out that let's see if 60 does it. So we're going to cut that. And then 1, 2, 3, 4, 5, 6. And woohoo, we got it. So that's pretty much it for drawing our shapes. And now we're going to do a little side note. And what it is we want to put this to GitHub. So the way we do this, very simply, since we import it from GitHub, we click on version control. It tells us all the changes we made. So, but I'm just going to say I added simple.py under shapes, and I'm going to click on commit and push. And it eventually will come back. And now if I reload this page, notice that shapes is here, and notice that simple is here. So that's how you're going to get work to me, homeworks and assignments as we move forward by doing this process. All right, so now we'll click back up to 5. So if we look at all of these over here, you'll notice that there's a lot of repetition for all of this. We're basically, forward, turn, forward, turn, forward, turn. And we could do this. We could make a 50-sided figure if we worked it out right. But it's a little bit of a, like clearly you don't want to sit down writing for a long time. So I want to introduce a new language. And so I'm going to create a new file here. So I'll click on shapes and I'll do add a file. And we're going to call this repetition.py. We want to do something that repeats. I'll click over to simple.py. I'm actually going to literally cut the whole or copy the whole thing and paste it here, but get rid of all the stuff in the middle. And actually, I'm just going to comment these things out as well, just for now. We'll come back to it. So in Python, there is something called a for loop. It's actually a for each loop. That's what it really is. And it works like this. We say for, and then we give it a variable. And then we say what that should be in. And so I'm going to say range 5. And then notice how it indents. And I'm just going to print that. So now if I run this by coming here and saying Python repetition.py, notice 0, 1, 2, 3, 4. So what range 5 is doing, if I just say, like, let's say, this is going to print weird, but it'll be okay. Notice it just says it's a range from 0 to 5, which means it starts as 0, it goes through 4. But what happens in our for loop is saying for I in each of those 0 through 4. So the first time in the loop, I is going to be 0, then it's going to be 1, then it's going to be 2, then it's going to be 3. Or by contrast, we could say, like for number in, if we make our range go up to 9, and notice the colon and all that stuff. We got it. Now this is variable name. 0, 1, 2, 3. So it doesn't include the first, but does include the second. Now, so what this does, it lets us repeat things. We could even do things like sum equals 0 for value in range 5. Sum equals sum plus value. And then we can unindent, print sum. So this should be 0 plus 1 plus 2 plus 3 plus 4, which it is. And notice the first thing, it just loops, this one loops to 8, but then this is that sum. So we can use this for loop to go from one thing to another. We can also do it with different starting points. For example, for counter in range 5 to 15, and then if we say print counter, notice that it's 5, 6, 7, 8 up to 14. So it starts with this number, but doesn't include this second number. So we can do this to repeat things. So coming back to our turtle code, if we look at our square was, it repeated these 2 lines of code four times. So we can do that by saying for counter in range 4 times. So this will be 0, 1, 2, 3. And we can say crush to move forward by 50. And then crush to turn right by 90. And notice what we do here is we can have as many lines as we want in here as long as they are indented the same way. And there we have it. And so that's a lot more concise. And in fact, we can do our other ones as well. So for our triangle, and notice that now we're back indented to the outside, we can say crush color is red. Set its color to red. We can say crush go to, I think that's where we went. Let's see. Oh, negative 70, negative 70. And then we're going to say for counter in range 3, we want to do it 3 times. Crush dot forward. Let's go a little bit less. Let's go 30 forward. And we'll go 50. Doesn't really matter. 40. And crush dot right, we set 120. And we forgot to do our pen up and our pen down, so we will crush dot pen up do the move brush dot new. There we have it. And of course, we can do the same thing. And I'm just going to cut and paste this code here. Green. Let's say 70. Let's just try that. And we wanted to go, in this particular case, for the hexagon, we wanted to go 6 times. Let's make that 20. And we saw that the distance, the angle was 60. And there we have it. So again, that's pretty much, yeah, that's pretty much it. That's yeah, that is repetition using these for loops. So we're going to do another little challenge. So what I'm going to do is I'm going to create another file here. And we're going to roll it trace meetup. And I'm going to put this in here. And what you should do is pause the video and trace through it. Now, some of this should be very simple. We have, and actually this is not going to run because my indentation is wrong. And now it should run, but notice that I've got these loops are a little bit different. So try to make a guess at how you think this is going to work. And then only when you're done, then run the program. So type this in and then run it. All right, and I'm not going to run this because that'll force you to actually type it and run it and not just look at it. Okay, so that's a little bit more of a complexity in terms of the for loops, to show you here how we can loop in a different way. We can loop here, using this and this, and again, we'll talk about this more later on. So yeah, so that's using the for loop. So yeah, that's that. So now there's one other thing that I want to talk about for today, and when I post this, I'll also post matching parts of the textbook for you to read, which is going to add another file, and we're going to call this funcs.py. So even so, if we look at repetition, this is better because it's much more concise, but we're still doing like oh, didn't know I could do that. These 3 lines here. And these lines, this, and this are kind of the same thing. It's just we're doing them slightly differently. So what I want to show here is another abstraction in Python. And this abstraction is called functions. And the idea is we can make reusable blocks of code in Python. The way we do it, so here's an example. So make a prediction on what this will do, but then once you've done it, you can run it. So pause and then come back after. And you'll notice that I have an error because I want to add 3 on A. So make the prediction now with that. And notice it gives, A is 5. It calls, what this does is it calls add 3. So it calls add 3. A is 5. 5 gets put into this X here, X plus 3, and then it returns it. It sends it back. So functions can do things. They can even, you can say like here, print I'm in the add3 function. And it runs that and it sends it back. Or we could have a function that takes 2 parameters. And we could even do so, and we have multiple lines here. So we could say result equals A plus B, and then return the result. You know, and if we wanted to, we could print hello. You know, that's kind of silly, but we could do it. And in here, we could say something like add numbers. We could say R equals add numbers 20 and A, because we can use a number or a variable, and then we can just print R. And if we run this, there we go. So this is how we can write functions. We can write these reusable bits of code. And the format is, if you see here, it's the word def, then the name of the function, what we want to call it. Then in parentheses, these variables, these are called parameters, and the textbook has a much more thorough write-up of this. And then we do whatever we want, but at the end, we want to return some value that we can use in an assignment. And so this will then take the 20, put it in this A, take this A and put it into this B, make a result, print hello, just on the side, silly thing to do. We wouldn't do this for real. And then return result, which then gets put into. All right, so the final thing I'm going to ask you to do for next week, and use Zulip, and I'll put this all in the text, so there'll be a little bit more, is I'm going to ask you to try to write a couple of functions, and I'll put this in the Zulip post as opposed to in the video. And what you're really going to be looking for is ultimately writing functions that can replace some of this functionality. All right, so that was a lot of stuff we covered, but hopefully it was all clear. And I'll use Zulip for any questions, comments, thoughts, concerns. And yeah, we'll be talking online until we meet again next Thursday.